to the first part of Competency 10 quiz. In this video, we will answer questions relating to limits, derivatives, and antiderivatives. Number 1, what is the value of the limit as x goes to 3 for the rational function 4x minus 12, x to the third power minus 27? Okay, there's a couple ways to approach this. But first, let's enter it in the calculator. So we need to push y equals. I already have it populated. Now, if you haven't watched other videos with me, how you get that fraction is alpha, window, arrow over, and that would be number 1, okay? Right, but I'm going to actually clear that out. Okay, now, that's all good to go. And let's push the graph and see what happens. Ugh, not much help at all. Now, we could try to figure out what the value is by saying second calc number 1, enter, and then we need 3. So put in 3, and it's blank because there's like a hole in this graph that we can't see. And that's why the graph is not super helpful, but the table will be. Okay, so we need to push second graph to get the table. Okay, and there we are at number 3. Now, I had fractions in there, but they weren't super helpful. So this is what I did. I pulled them out by saying second window, and that's what I put in. Actually, I went straight to number 3. That's where I wanted to start looking at my table. And then I put in just a little bit. Of course, that really gives me a lot of decimals, but you can play around with what you put in, and that's the table increments. Okay, so let's go back to that table. Notice it bounced back to 3 for me. And this is what I'm going to do. I'm going to sketch out really quick to show us which one of these values that will work. Okay, first off, look at D. That's 0. Okay. Look at your table. Really, do you think that goes all the way down to 0? It might. So we need to do a little something with our rational value. If you remember, I'm just pulling out that rational function. If you remember, you can factor out the same value from the numerator and denominator. Well, the numerator kind of tells me what I need to do. Okay. And so I need to pull out x minus 3. Okay. Actually, you can more need to say that you're pulling out 4. Pull out 4, then in parentheses, you have x minus 3. Okay. Now, the fact that 3 has an error, this tells me that in the denominator, I would have an x minus 3. So we have two situations telling us to pull out x minus 3. The numerator, it just happened naturally. And then in the denominator, you may not be sure how to handle this type of function where you don't have any other values between your leading term and your constant term. Okay. All right. So that being said, the first reason is my calculator shows an error. Okay. So when something is in the denominator, it tells me, it kind of like clues me in, right? Because this would be saying x equals 3. But we can't have x equals 3. Okay. Either way, you'll see. And then when we finish out, if you know how to factor these out, what we get when we factor this out is x squared plus 6x plus the 9, okay? And you can play around with that and look at it later. By this time, we've done so many of them, you're probably very used to seeing this. Okay, then we need to cancel those. Well, lo and behold, what's left in my numerator? It's 4. Well, which options give me that? Well, that's only option B. Okay. Now, we have another way to judge this, which is probably what you might want to lean towards when you're taking a test. Okay. We need to see about what that would equal. And look at your calculator. That value, decimal value of B needs to be between 0.1486 and 0.1477. If it is, then we absolutely know that we have the correct option. Okay, well, let's just back out of the calculator and say 4 divided by 27. And there you go. It does. Okay. And then we know now 0 is not in between. So just put the others in the calculator to prove it to yourself. 8 divided by 27 is, well, that value is too large. Okay, so that's not going to work. And 3 divided by 27 is a value that's too small. Okay, so what we needed was this value here is, we'll squeeze in there very nicely. Okay, 8, 1. Okay, so we know our option is correct. Okay, now let's look at number 2. All right, consider the following graph of G. That is a piecewise type function. Okay, it's in sections. Which one of the following statements is completely correct? Now it has to be completely. There are 2 parts to each answer, and we have to believe them both. So let's begin with A. The limit of g of x as x goes to 0 from the negative side exists. Yes, I believe that. If you come from this direction, it does have a limit from that one side. Now let's look at the other part. And the limit of g as x comes from the positive direction to 0 does not exist. So I believe both of those. So I'll give that a check mark on both. See, and we know it doesn't exist because look at what's going on between the graphs. Well, obviously on the right-hand side, everything's stuck in that first quadrant. So, yeah, we can't believe it. Okay. All right. And then also, if you're just looking at this bottom part, it's not going to exist. There's like this gap. There's nothing there. Okay. So let's go to option B. Now, if we approach, it's saying if you're going to approach, uh, if you are approaching G at -4 here, it's saying it exists. I absolutely can't believe that because it may exist coming from the right, but it does not exist coming from the left. So the minute that one is out, the whole thing is gone because it has to be completely correct. I don't believe it. And yes, this is true, but the first the first part of the answer is not true. Okay, let's look at C. If you approach -2 from both directions, you find a limit to be -1. Okay, I buy that. Absolutely. But now let's look at the other part. G of x is continuous at x equals 0. See this great big hole right there? The minute you see that and it's saying continuous, it's not saying about the limit existing. Those are not the same thing. So, no, I disagree with the second part of that answer. So, that's not going to work either. Okay, now let's look at D. the limit as it approaches 0 from the positive direction is -1. Okay, I'm going to have to say no. There's nothing over there. If it approached from the other direction, I would believe that. But I'm going to have to say no. There's this great big gap right here. See? So there's nothing even to work with on that side. So I disagree. And then the other half that says the domain of G is all x greater than -4 in the real numbers. So they're saying that every single number on the right-hand side will satisfy G of x. Well, we just said several statements that say that's not true. So we've already said it isn't true. So obviously that answer is not valid either. So in the end, we did go back to A, and that is our value. Okay, let's go to number 3. Okay, number 3. If this rational function is in reduced form and the limit of this function as x approaches infinity equals infinity, then which one of the following is true about the value of n? Okay. If you remember the rules, okay? If we had, first off, you have to have as x is approaching infinity. That's the only time that they're going to apply, okay? If these coefficients, let me highlight, if these, not coefficients, if these exponents in the leading term, leading exponents, I say, if they're equal, then uh, we use the value that we have in our coefficients, okay? In that case, our limit would be 3, and that isn't the case, okay? Well, they're not giving us an option for that, okay? And that's how I do believe that that's how they got this and this. But the value is infinity. And in order for that to be infinity, then the number, the exponent in the denominator, the a, had to be greater than the exponent in the denominator. So n must be less than 8. Okay. Remember, if they're equal, then because of this infinity, okay, if they're equal, then this right here would say 3, and it does not. Okay. If it's the other way around, then if let's say 8 and n were switched, well then no, that wouldn't work either, because n would have to be 9 or greater. If n was 9 or greater, then the limit would be 0, and it isn't. They're saying infinity. So no matter what, n has to be less than 8. I mean, that's just what the definition is. We have no other option. Okay, so now let's look at number 4. Okay, so we have to kind of think this through and work with the definitions of what is continuous or what is not continuous continuity. Okay, at which point or points is h of x not, and I just noticed this should be h. We've already used g. Okay, is h of x not continuous? Okay. When is something not continuous? Okay. When we have a point that is open, remember? So at that coordinate point, it's like a gap. It's open. There's no value. In the prior question, we had 3 had an error. Well, that's what's happening here at -1, right? then we know it's continuous if the line is present or our curve is present on both sides of our point, which this would be continuous, okay? All right, but I'm going to erase that because we want to talk about what is not continuous, okay? Now, the 0.25, this one right here, that's tricky. It is still a curve, even that though it has like a point. It is a closed point and it has some kind of a curve on each side. You can come from both directions and it is filled in. So this means it is continuous. Just because it is a corner type point does not mean it is discontinuous, okay? However, let's look at this endpoint right here, the 5 and the 7. We have something coming from one direction, and that's it. We get there, we stop, and nothing happens. Obviously, it has ended. It is an end point. There is no continuation of the curve. So that on its own logically tells us it is discontinued because it really has completely stopped. It has completely discontinued. So obviously, only here, no. Only at the end, no. And this can't work because we see that D doesn't work because -5, 0 is super obvious that it's continuous. That's just textbook classic definition. And so then the only two things that work for us are C. Okay, this is the last question in this first section of our quiz for competency 10. And once again, thank you so much for watching and sharing and liking our videos and subscribing. Happy testing!